we are. You're presenting. Yeah, right. Yeah, it's getting that one.
Good afternoon, everyone. Hi, I'm Gary Polinsky. I am a co-chair for the board for St. Louis Business Intelligence User Group. Welcome to today's session. I think you'll find it interesting. We'll begin with a little news about from past, and then we'll dig into our first presentation. Thomas Abraham is here to present on Microsoft Data Science and Azure. We'll take a short break after he speaks, and then we'll have a demonstration from Panorama Software. And we'll finish up with a raffle, so stick around. There are prizes to be won. Lunch today is provided by Panorama Software. Thank you. If you haven't gotten some food and you would like some, just head to the back of the room and grab some. Upcoming events. On June 14th, the SQL Server User Group has a meeting. Covenant Technology Partners will be our lunch sponsor. And Sean Nesser from Microsoft will be speaking on big data for the SQL Server professional. And Kathy Kellenberger from Linchpin People will be speaking on introducing SQL Server 2016. Then on July 12th, in the evening, we'll have a joint meeting between the SQL Server User Group and the Business Intelligence User Group, and Kathy Kellenberger will be back to speak about SQL Server Reporting Services 2016. Coming up later in this year, in October, we have the PASS Summit in Seattle, Washington. You can get a discount for that if you register using this code provided here on the screen. And you can get what?
So it gives you a $150 discount if you've already registered. It's not retroactive, but we do get credit for those who do register with it. And then something which just came in that didn't make the slide is on September 10th. There's going to be a SQL Saturday here in St. Louis. It's a one-day mini conference. It's going to be back down at St. Louis University. We're number 542, so if you Google or go through the PASS website for SQL Saturdays, you're able to register. They're also looking for speakers, and the registration is usually nominal. It's usually like $10, and it covers the lunch. So if you don't show up, they don't have to worry about having all this pizza or sandwiches and having to pay for it. So it's just the only expense is for the lunch. So it's a one-day mini conference. There's different tracks. And also, if you're interested in volunteering or helping with us, just let us know. So there's a takeaway sheet that gives you a lot of the information of other upcoming dates. We're still scheduling out the rest of the calendar for the meeting.
I know it's loosely related, but there's a big data conference also at the end of July here in St. Louis. I think it's called StampedeCon. It's going to be the last week in July here in St. Louis. We can provide some information. If you look up StampedeCon, it's a big data conference here hosted in St. Louis. It's fairly large.
Yeah, if you do that, we can send an email out.
Yeah, send us information. We'll post it on our local chapters. Okay. And by the way, if you don't know her already, that the person who was just speaking was Julie Bloomquist. She's the co-chair for the SQL Server User Group here in St. Louis. Thanks, Julie. And that was the other person was Eddie Hendricks with Microsoft. The PASS Summit. There are over 200 technical sessions. There are expert industry speakers, lots of networking opportunities. And again, here's that code. There's past elections are coming up this year. You need to be registered with a profile, with a MyPass profile by June 1st in order to vote. Elections take place in September. There are all sorts of virtual chapters. If you have an area of interest, there's probably a virtual chapter out there for it. So by all means, get involved in that. Take advantage of it. Some of the virtual chapter meetings that have happened here this month are the kids program, teaching kids programming, server encryption. So there are all sorts of things you can take part in the virtual environment. So upcoming SQL Saturdays are happening all around the world. We have a SQL Saturday. Julie, do you know what the SQL Saturday is here for the one in St. Louis?
Yep, I just said it. It's September 10th.
You did say.
And it's number 542.
September 10th. Well, somebody in this room was not listening, and that was apologize. PASS would not be successful without you volunteering. Please visit volunteer.sqlpass.org to check out a variety of volunteer opportunities. You can also stay involved by connecting through social media, through LinkedIn, Facebook, Twitter, and the PASS website. So our first presentation is, and our theme is BI to the max, is machine. Just to talk a little bit about it, machine learning is letting algorithms look through data for patterns, meaningful visualizations, help explore and communicate those insights. In short, it's the most sophisticated tool we have. Predictive analytics is no longer just a buzzword. Businesses are being transformed across the world due to the power of advanced analytics. Microsoft is at the forefront of this transformation with Azure machine learning. In his talk right now, Thomas Abraham will give a brief tutorial on how to get started with machine learning and how to choose the right algorithm and how you can deploy a model for anyone in your organization to drive business. He'll show you how easy it is to get started on machine learning without being a data scientist. Please welcome Thomas Abraham.
All right, can you guys hear me? No. Oh. That looks fine. All right. Hello, everyone. Thank you for setting apart your time to come here for this group meeting and actually coming here to listen to this talk. I think to start off with, I was on your side until about 3 months ago, meaning I was a user of all these tools. And I'll explain some history and background, and I'll explain how I eventually ended up here in Microsoft. And what is the big motivation? What is it that I see here, and what excites me? Hopefully by the end of this talk, you guys are excited as well. So as you see there, my background is actually I have a PhD in chemical engineering. I finished about a little more than 10 years back at the Ohio State University, for those familiar with that. And after that, I joined a chemical company called Nalco, based in Chicago. And we were focused on IoT devices, looking at data, and that's how I started playing around with data. And then it sort of evolved where we started looking. So when I walked into my job the first day, they said, okay, all our data is inside the SQL server, figure out how to get it out, do some analysis on it, build models, do those kind of things. And my background was in modeling, not the Zoolander type, the other kind of modeling. But I wish it was the other one, but it doesn't work. So I started doing a lot of stuff, and then eventually that morphed into building complex models, algorithms, and then slowly I went into machine learning because that seemed like the eventual next step. And sort of the breaking point for me was I attended a Gartner BI conference, if anyone has ever attended that. It's a really informative conference. So I attended one of those a few years back, and remember, my background is in engineering. I don't know anything about BI. And so I listened to all these different tools that are available, and it just got me all excited. And I said, why not borrow some of these tools into our industry and use that? I started using machine learning. I started using Power BI, and I was literally selling that inside my company, doing stuff for other people with other groups. And then this opportunity came about, and that's why I'm here at Microsoft. And it's pretty exciting. So I didn't have an agenda slide because my agenda is to basically do about 145 PowerPoint slides there's going to be a little bit of PowerPoint, but it's just to set up so that you understand everything else that I'm showing. But I'm going to be doing a lot of demos. If you have a laptop in front of you, it's cool. You can check it out. But otherwise, you can follow along, and I think we can share some of these slides later so you guys can look through the links and sort of go through it. But in terms of a broad agenda, my idea is to sort of paint the big picture on what Microsoft is thinking with Azure Machine Learning, and I don't know how many of you have heard of Cortana Intelligence. So that is sort of the big picture from Microsoft, and Azure Machine Learning is just one small part of it. And you need to understand the big picture of what Microsoft thinks about it and where Azure Machine Learning actually fits in that. So I'll explain about that. I'll talk about Azure Machine Learning, and then like we talked, I mentioned in the abstract, I'll talk about how you select algorithms, and I'll work through a couple of real-life problems, and you can see how you can solve that. I think one of the interesting things is, even though I do have a PhD, I wouldn't consider myself a data scientist. I'm not a data scientist in residence here. I am just a data solution architect, but I use a lot of these ideas in helping customers, come up with the next step, right? You talk about analytics maturity, so you talk about doing visualization. The next step is predictive analytics, so that's what I focus on mostly. So to give you the big picture, primarily the three trends that you see with data that is transforming organizations across the world. One is big data. So you have a lot of devices that are collecting data from different places, and you have data that's on-prem, data from the cloud, all the different kinds of data that is coming together. So you have this trend of big data, you have this trend of cloud, but what is it that makes sense of all of that is really the intelligence that you can put behind all the data, and how can you transform all that data into something of value. As BI professionals, you guys understand that. But think of it as you're doing some of that ad hoc, right? Someone asks you for something, you're building a report, someone is looking for a certain kind of, a certain question to be answered, you're doing that ad hoc, but a lot of that can be automated. How do you automate some of that intelligence? How do you take it to the next level? So that's adding that intelligence layer to drive business transformations and to actually drive new business, which is what my previous company did. We were a company that just sold chemicals, and then it became commoditized because everyone sells the same thing. So how do you differentiate? So what we did was we built a box that could actually intelligently feed those chemicals based on some sensor measurements. And then, the customer didn't want to go and check if there was chemical in there. So what we did was we piped that data into a website so customer could sit at home and just look at it from his website and say, hey, there's chemicals there, there's all these different things. So we transformed how we did business. We were no longer just a chemical company. We became a chemicals and services, and so we differentiated us, right? So I'll talk more about how you do that to transform your business. So again, this just shows all the different pieces. So you have the business apps, your custom apps, different sensors and devices that's collecting data and bringing it together, and you're going from data to some sort of action, right? Actionable information. And Cortana Intelligence broadly sits in between there, right? And it does a whole bunch of different things, which I'll go over. But the outcome is that it helps people take action. Maybe you have some apps that look at that intelligence and take some action. And you have some automated systems as well that, based on some business rules, now it automatically takes some decisions. These are just some examples of what Microsoft is seeing. And if you look across predictive analytics, this is what people are doing, like retail, remote monitoring, demand forecasting, looking at the weather today, right? If you looked at a 3-day weather prediction, you'd be able to say that you're probably not going to sell a lot of things today, except maybe umbrellas, right? Or ponchos. So demand forecasting, in the financial industry, risk and compliance management, right? Inventory management, marketing mix optimization, that's getting the right product at the right place at the right time, right? So how do you market the right way? Personalized offers. The industry where I came from, we focused on oil and gas quite a bit, so predictive maintenance was very important. Operational efficiency was very important because you had large pieces of equipment, that were huge capital investments, $5, $10, $15 million. But if they broke down, maintaining it just cost maybe $100,000 or so. But if they broke down, now you had to replace that entire piece of equipment. So it's very easy to show the value of the data there because you're preventing huge capital investment from going to waste. Cross-selling and upselling, so that's all about exploring new business opportunities using the data. All of this comes in through that pipeline that I talked about. That's the data and transforming that to intelligence and using some of the Cortana Intelligence tools. So how can Cortana help you? So this is basically showing you the different parts of Microsoft Azure, all the different services, and I'll be focusing. Machine learning comes inside the analytics and IoT. I'm not sure how many of you have seen this slide, but it is part of the analytics and IoT suite of products. But I was just highlighting there that it all fits into one platform, and it's all integrated, and it works seamlessly with all other parts of Microsoft. So again, I talked about Cortana Intelligence, and these are sort of the different pieces. So you have something for information management, you have something for big data, and then you have something for machine learning and analytics, and then you have something that focuses mostly on intelligence, and I'll talk about that, and dashboards and visualization, Power BI, which is down there in the corner. Not that it's not important, right, Steve? Yeah. But we talk about Power BI and visualization. To me, in my previous role, I could do all kind of magic in between, but unless I could throw the visualization, put it in front of customers or internally amongst people, nobody understood the value of it. So it is, I think, one of the most understated, even regardless of what you're doing here, be it Azure machine learning, whatever else you're doing, the visualization part is still important. You can never take that out of that equation. But I just want to show you the whole stack of what we have. This is just focusing on the intelligence part. So here we have Azure machine learning, which is one part. And basically what Azure machine learning is machine learning in the cloud. Okay, so it is completely run through a browser. There's nothing that you download or install on your computer. you log into a website, and I'll walk you through all of that in a little bit. There are other solutions if you're looking for something that needs on-premise and combined with the cloud, but and there are ways of integrating that with Azure ML as well, but Azure ML as a product itself is a cloud-based service. There are a couple of other things that are there in the stack. Azure Data Lake Analytics is our big data analytics for doing a lot of complicated analytics jobs against several different data sources that you see here. I will not be talking about that, but we have a lot of big data analytics options in there, and you can see that there, but I just put it there just for completeness, because often what we see at Microsoft when we go into a customer and they're already doing machine learning, they're probably doing it, on some of the big data, right? So for them, for those people, they like to start with these options and then move on. And then there's Stream Analytics, which is for real-time data. So this is, for example, data coming from a temperature sensor or a water meter or something like that, where you're running. So it looks like a SQL query, but what you're doing is you're saying, hey, look at my temperature over the past 1 hour. So you write a query that says, it's like there are different ways of structuring that query, but you can look at real-time data and then do analytics on it. So you can say, for example, if you are trying to detect credit card fraud, right? So you're saying, hey, keep looking at my data every second, and that's what it's meant to do. Stream Analytics is meant to handle high throughput, high frequency data coming in through it, and you can set up these really complex queries and then decide what you want to do with it, right? You can say, hey, alert someone, do aggregates, write this to this table, and so on. So that's an important part of all this analytics. This part here, I'll quickly go through. Cognitive services, again, is for people who don't want to deal with the intricacies of machine learning, right? So there's so many aspects about it. What Microsoft has done is years and years of Microsoft research. They've taken it and sort of built these standard packages on dealing with different issues. And, IBM sells this as, I think they call it the API cloud, the API world or something like that. But this is basically a bunch of APIs and SDKs where the intelligence is sort of packaged and there are ways to interact with it. So for example, the face detection SDK, right? So all it's saying is, hey, give me the inputs and what are the kind of outputs you want. So I think it does something simple as, is a face or not a face. There's more complex ones that does emotions as well. So, we did this at a demo recently where, people would stand in front of the thing and it says, married. And they were like, how does it know that? Oh, it looked at your hand. So it looked for a ring on your hand and it said engaged or not. So things like that. So you're not focused on the insides. You're just saying, hey, how can I get value from some of this? And this is all packaged in terms of APIs or SDKs, and you can use that. So that's another thing that Microsoft does in terms of the cognitive services, and you can go through that. But, so this is part of the search engine that's been exposed, and these are all charged based on several thousand transactions. So for every 10,000 transactions, you pay a certain amount, and that's how this is sold. The bot framework, some of you, if you follow Build, this was announced at the last Build conference. This is where, for example, you can automatically order pizza. It's basically a bot with business rules built into it that you say, hey, if you get a certain kind of message, this is how you translate it, and this is what you need to do, right? So in this case, somebody is saying, I need pizza. Hey, do you want the usual? Blah, 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 and we'll send you the pizza, right? Not through the internet, it'll land in your house. So it's not like it sends an emoji there, hey, that's your pizza. So it actually physically delivers a pizza to your house, right? So that's the bot framework, and you can think of infinite possibilities on what you can do with that. All right, now it's demo time. So I'm going to be starting off with and before anyone mentions it, yes, I am using Chrome, right? Okay. But this is the URL for Azure Machine Learning, okay? So it's studio.azureml.net, and any one of you can go in there and get a free account. In fact, this account that I'm doing this demo today is a free account. So you can log in there and you can create a free account. There are some restrictions on certain things in terms of, and those are actually listed here on the website, but studio.azureml.net is the place to go to get started. Okay. And what I'll do is, okay, before I go on, how many of you know what machine learning is? Most of you do. Some of you, right? Without going too much into detail on what it is, I'm assuming you guys know, so I'll just walk you through what is it that you, how you start off with, and just the lay of the land on how you get started. Because sometimes you see some of these tools, you click through it, and you're like, okay, I'm not sure what to do next. So hopefully I'll give you enough of a tutorial that if you log in, you create an account, you know where to start. But ideally, the best place to start if you're trying to learn is actually the gallery. So if you go there, click on gallery. So this gives a whole bunch of examples, and you can go into any one of the experiments. So the one that you want to do that I'm going to talk today mostly is about experiments. So if you click on experiments, then it shows you all the different experiments available. Actually, you can create your own experiment and upload it. It's absolutely an open gallery, but there's ones that are submitted by Microsoft employees, so I'd recommend you start off with one of those. And if you search for the word tutorial, you can find ones that are used actually in a tutorial that will actually describe all the steps for you. So that's ideally the best place to start. But if you're logging in for the first time, you want to take a look at it, and what you do is you click on one of these, say this experiment, and then open in Studio. So when you hit open in Studio, it will actually open that same experiment. It will say, hey, do you want to copy that experiment from the gallery onto your workspace? And then you say yes, and you will have that experiment copied over, right? So I'm going to select yes. All right. So, all right, I don't need that now. So here is an experiment, and everything on this. So this is sort of the experiment canvas, if you will. So this is where you run a machine learning experiment, right? So this is Studio. What you see on the left-hand side, I'll walk you through what is here. So on the left, you have the ability to sort of organize all your experiments and the various things that you do into projects. So the idea with that is Azure Studio ML is meant to be a collaborative tool, which means, if you're working with several other people, and I'll explain why you need to do that, is, someone sharing data, you need somebody to look at something, you can create a project and then share it. So there's an aspect of user management and managing your projects in there. And what you can do is also you can share this workspace. So if I had more than one workspace, you did this drop down, you'll see those other workspaces in there. Experiments is really the meat of what you do in Azure Machine Learning. This is where you go, you create experiments, you take your data, you build a model, and you deploy it. That's what you do mostly here in Experiment. And web service is where you actually operationalize this. So once you create a model, now you have the ability to push that out into the world, right, for consumption. And you can do that using web services, and that's what you'll see here. Notebook is an interesting concept. It's the ability to run what's known as Jupyter notebooks with either R or Python. And R and Python are one of the two most common open source machine learning tools that are used across the world. And so what Microsoft has done is, normally if you're doing R or Python, you actually have to download the tool, install it, and run it. If your computer is not fast enough, it's going to slow everything down. Here now you have a UI that's completely on the web that you can do R and Python code on it. There are some restrictions on it, but you know, for most people it works. So you're able to take some of your R code, and the cool thing is you now have the ability to interact from the R or Python environment with Azure ML as well. So you have the ability to use your existing open source tools with Azure Machine Learning. Data sets is where you upload data sets. So if you have your own data sets internal to your organization or something you want to start an experiment with, this is where you upload them to. I think the free workspace has a limit of 1 gigabyte, I think. But then when you get the paid version, that goes up to 10. 10 per workspace. You can have multiple workspaces. Trained models is where you have some of the trained models. Again, keep thinking, I know I can't get Zoolander off my head, but this is where you build the models and you put it in there. And these are the ones that are exposed to the rest of the world. You put these into your web services and you build predictive the web services using these models. But it's a good way to manage models and comparing them and so on. So one of the things you want to do is, say I use algorithm A, then I use algorithm B, right? How do I know which one is better? So one of the ways you do it, you sort of save it, and then you use that to compare. You run some tests to see which one is better. And settings just lets you manage your users and so on. All right, so we're going to do a live demo here. So we're going to start with, click on New, and start a blank experiment. Right. So I'm not going to actually do an experiment, but I'm actually just want to show you what the different options are. So on the left-hand side, you will see all the different modules that are available. On the right-hand side is usually a description of the module that you're clicked on, right? So for example, these are groups, so you have saved data sets, trained models, transforms, data format. Don't get overwhelmed with all these names, but once you start doing these examples, you'll understand what they mean. But for example, if I want to get a data set in there, right? So I go in here, get to my data set, and then just drag it and drop, right? Anytime you drop a module in there, what you'll see that dot, and that is something that either gives an input or an output. So the ones on the top are usually inputs to the module. The dots on the bottom are usually outputs from the module, right? So if I right-click on that dot there and hit Visualize, it actually shows what the data is in there. So in this case, it's saying I have 93 rows, 6 columns, and these are all the columns: location, Gini index, and so on, right? So these are the columns. It actually does little statistics in there, so you can click through. And this is so that you can sort of examine your data. And this, I tend to do this quite often, because what happens is sometimes you've created a data set, maybe CSV or whatever, you upload it, something screwed up in between, and then you look in here and it looks different, right? So you want to make sure that your data looks fine, so that's why you hit Visualize quite often there. So this is true of any module. So if I drag another module in here, so for example, if I say I want to, and it's pretty easy to find the module. So if I say join data, right? So that found that, and then I just drag that. And when you pull this, it will highlight by green showing where that can attach. So if you have multiple modules, right, multiple data sets, it will actually highlight in green. What's happening here is now on the right side, it's showing what options that module has. So for example, this market data by itself has no options. I mean, it's just data. There's nothing you can do on there. This one shows some options. In a nutshell, that's how a lot of this just works. There's a whole bunch of modules on this side. Depending on what you drag and drop onto your experiment, you bring it in there, and then I will actually work through a real example later as we talk through this. Any questions so far?
I've got one.
Yep.
So when you're doing the visualization, can you sort by a certain column by clicking on it, so you can get the minimum and max of bad data?
No, not right now. So it's a very, I would say, non-interactive. What it's doing, it's meant to show, like I said, in most cases, what I use it for is just verifying that it makes sense what I put in there. The other thing that you would do in there is Azure Machine Learning by itself interprets data a certain way. So for example, if you put in a binary where you're only wanted zeros and ones, sometimes it might take it as an int. So depending on how your data looks like, you probably need to do some transformations on that. So generally that module is meant for that, so you can examine your data and just make sure, okay, this did everything. Because once you're pushing stuff up to the cloud, it has its own way of figuring out what the data is and categorizing it. All right. So my idea was to do this, to sort of go back and forth between PowerPoint or Death by PowerPoint and the actual machine learning studio, so people don't fade off, especially after lunch. I know I'm starting to fade off a little bit, but so I'll talk about machine learning basics, which is something I promised when I said I'd give this talk, because when I started looking at Azure machine learning, I had some understanding of what machine learning was, but I had never applied it in my life earlier, right? So I took some training classes that explained it to me, and when I saw the tools that are available, it takes you to the other extreme where you want to play with it, but then you're struggling with understanding what it's telling you, right? So you need to understand some of the basics, but then take that and then use Azure Machine Learning to understand what it's trying to tell you, because it can tell you many things depending on what, there's so many options in there in terms of the algorithms, so many options. Within an algorithm, you have so many parameters that you can change back and forth that you look at that, you're going to get overwhelmed. So the good thing is a lot of the defaults work really well. Like if you drag some of those modules in there, stick with the defaults, they work really well. But if you want to go advanced, you have that option as well. So before I talk through the next thing, to talk about, there's two kinds of machine learning. One is known as unsupervised and the other is supervised. So unsupervised learning is where you're trying to find some sort of hidden structure amongst data, right? So you don't know exactly what you're looking for. So there's no error, which is typically how you look at some of these predictions. Is my prediction good against some error? And k-means clustering is one of the most popular ways that you do it. And it's been used for a long time, but now it's been adapted into machine learning. So that's what's known as unsupervised learning. And I'll give an example here. So for example here, someone wants to make clothing size. You can't get one size that fits all people. So you sort of group people into similar categories, right? So small, medium. So you're not getting an exact fit, but you know that if you design a small shirt this way, it will fit a certain range of people, right? So that's sort of categorized. But previously, you don't know what that population looks like. Same thing with text documents, right? So you don't know how to classify your text. So you're trying to find maybe written reviews, for example, right? You're trying to find who are the people who are strongly for you, who are against you. There's no way of describing that and looking at, you could use like something like natural language processing, but a different way of doing it is this k-means clustering, right, where it goes through that and sort of separates it based on some criteria. Target marketing. So that's where you're going through a big piece of data and you're trying to group the people that you have into different groups, saying that, you know, I see something common over here, so I'll put them in a cluster or put them together. And there are different ways and methods of doing that, but that's unsupervised, right? There's no one actually saying, you know, put them in a separate group. It's just automatically going through the data and actually building that. This sort of explains, without going into the math, which I could for the next hour on just this, but you know, what it's doing is it's trying, if you have a spread of data, what it's trying to do is it's trying to find a center for each of the data and then trying to minimize where that center is as it's going through the iterations. So that's what clustering is. You're trying to find what's the best center I can find. So in this case, it's trying to cluster 3 data sets, right? And it's saying, okay, it starts somewhere here, and slowly it's saying, hey, you know, I think there's a cluster over here. So it says, okay, my midpoint is here, and all these points are very close to that midpoint. So if you look at when it stops at like step 12, you'll see that green mark, for example, is somewhere really close to that third cluster there. In a nutshell, that's what clustering is. You start off with a data set that's all over the place, and it tries to find out how best you can separate it into multiple groups. So it's demo time, right? So this is again an example from the gallery, and it starts off with the business question, right? Where do I open my next restaurant? Okay, so this is a scenario. You are a restaurant chain, and you know you've started maybe 15 restaurants, 20 restaurants. You have some data from there, and you're trying to say, okay, which city, which neighborhood should I build my next restaurant? What you can do is actually collect data from the existing restaurants that you have and assume that it's a good representation of the neighborhoods that are available. In this case, you have a much larger set. But typically in most data that you have, there's different features, and a lot of the machine learning people, you know, so if you go to some cool parties, you know, and people will say, hey, have you learned about the latest feature engineering? Like feature engineering? So then now that you've attended this class, you know what feature engineering is. Okay, so feature engineering is where you extract interesting features from the data to make sense of it. So for example, one of the feature engineering that's done in the data is this Gini index, which I didn't know until I read this, is basically looking at neighborhoods and, you know, looking at the gap, the income gap, right? So that seems to be a factor when they were looking at this restaurant data in terms of influencing what the market was, right? So in a nutshell, feature engineering is basically taking data that you have and transforming it into something that makes sense for your model. And that doesn't happen on the first experiment on the first day. It is something that you sort of iterate and get to it, but, you know, next time you're at one of those parties and they say, hey, have you done any cool feature engineering lately? You tell them, yeah, you know. So, you know, I was talking with some people who are focused just on SQL, for example. So where do we do feature engineering? I said sometimes on your SQL server, because those people who are doing the machine learning part will say, hey, I need to have this calculated from my data, right? So sometimes that feature engineering will be done on the server side. Sometimes you can do it on the machine learning side. Again, it depends on so many different factors, like how much data you have. But if at the end of the day, if you're someone who deals with a lot of data, the feature engineering part, I think, is very critical in terms of feedback to people who are dealing with the raw data itself, right? So I can give you another example of feature engineering, for example, GPS data, right? So if I'm if I'm tracking taxi cabs, right, that are going around the city. So a cab that's gone for 10 minutes will have so much data, but another cab that's gone for an hour will have much more data, right? So how do you then build a model that takes, you know, a 10-minute data and a 1-hour data and build some sort of sense from it? So feature engineering is something where you extract data. You don't use the raw data. You don't use the GPS coordinates. You transform that into something like, okay, this is the time they started. This is the time they end. They started at this point. What was the radial distance from the final point? So you're sort of transforming the raw data into something that makes sense for the model, and that's what feature engineering is. So what we're doing here is we're going to start with data from various cities for this restaurant, look at different features, and see if we can train it and sort of cluster it into groups of cities that are very similar. And then what it does, it assigns a cluster number to each city, and then you can output the cluster assignments, and then I'll deploy that into a web service that somebody can actually use. All right. Any questions so far before I go into this demo? We still online? Okay. All right. So this market data actually represents the data that I was talking about. So you have the location, you have the Gini index. Like I said, it shows the spread of, so you can see the minimum, there's 0.41, and the highest there's 0.45 or 54. There's another one for population, approximate land area. And if you look at this, some of this is the raw data, some of that, you know, for example, you don't know what units these are, right? But it doesn't matter. What machine learning will do, what Azure does, is you have the ability to normalize data, so that way there's no skew in the data and so on. So I'll show you how that's done. And that can sometimes affect your model, especially when you have data that has a lot of variance. So for example, if you're trying to build a model that has a 0.4 and it has a 10,000 or something like that, what happens is that will skew your model, so your model won't work that well, and so that's why you tend to normalize the data. So that. So I'm going to input a module here that says normalize my data. I put it in there, connect it. I'm selecting my method to be the z-score. I will not go into details of that, but it's the statistics that you use include columns. Right? So now I'm saying these are the data that I want to normalize with the z-score. And so after I've added a module, the next thing you do is you just hit play or run, right? Looks like a VCR button. And when you do that, what it's doing is it is actually running in the cloud, right? So it actually flows that logical flow from top to bottom. So it started with the data, and it moved on to normalized data. So now if I right-click on there, on this here, and hit visualize, now I can see my other data is normalized, right? So before, where you saw population was sort of skewed in that it had like 22,000 and so on, now you have this normalized data, which is good for building models. So the next thing we're going to do is to actually train a clustering model. So I'm going to drag that. Right, so what I did was, if you go into the options in here, you get a whole bunch of different options in terms of what you want to do with your machine learning. So in this case, we want to train a model, and I know that I'm going to do clustering, and I will explain these things here. Anomaly detection, classification, those are basically the 4 categories that are there in Azure Machine Learning. So I picked clustering, and under clustering, there's just one kind, that's the k-means clustering, right? So here I'm saying, okay, and when you hover over there, it says it's an untrained model. Notice how it says exactly where I can connect it. So if I try to connect it over here, that's not going to work. It needs to be connected here, right? So this one, so this, what this module does is it actually trains the model, and I'm going to say, you know, let's train this. Actually, all of this. So you're just saying, what are all the things based on which you want to cluster this, right? So to go with the example that I gave you earlier, remember we just had an X and Y. So I was showing you an X and Y plot, right? So imagine that now we have 6 dimensions. So when we did the X and Y plot that I did earlier, you just had 2. That was just an X and Y. Now you have about 6. So that's how many variables you have. And then you can run this. Right? So again, now what it's doing is it's taking the k-means clustering algorithm, using it against normalized data, and it's done, right? So it's done training that model. And if I right-click here, I can save this as a trained model. The next thing you can do, without going through more steps in here, is what you do is setting up a web service. Okay. So I've already done this earlier, so we don't have to walk through that. So this is what a web service looks like. So again, let me just show you the actual experiment that I did here. So this is the same experiment that we talked about earlier. So you take the data, normalize it, change it to clusters, and then what you do is you hit set up the web service, right? So when you set up the web service, once you do all this, what you get is this thing here. So this is interesting because to get to this point when you were doing machine learning earlier took several months. Because what you had to do was you had to explain to someone who was a developer, okay, this is the code that I used. Now make this into an operational model. Now this happens in seconds, right? When I saw this blew my mind, because I was working on different things, projects that I couldn't find enough people that I could transfer my knowledge to do this. This now happens in a few seconds. So there are different aspects about this. One is you can send data, what's known as a request response, where you say, hey, this is one piece of data, give me my prediction back. And then you have something called a batch execution. And the cool thing about this is if you click on the API help page here, it actually shows you all the information you need So it says this is the URI that you can get it. This is what a sample request looks like. It actually gives you a response. So everything is in JSON. And then it actually even gives you sample code. So it gives you C# code that will specifically let you just access that. So if you have some existing application that needs some of this data, you can just literally copy paste this C# code into that, and you can have it up and running, right? So it's the actual code with, if you look in here, it actually has the column names exactly as we had inside the experiment, right? So it has all of that in the code here, and you can actually just copy paste this code into your application and be able to access it. The other thing that blew my mind was the Excel spreadsheet. So as soon as you create the web service, you now get an Excel spreadsheet that you can download. And to me, even beyond the web service, because a lot of the things that you do when you're trying to build this model is you need to send it to a few people and say, hey, does this make sense? And previously, that took a long time, right? Because you had to go send it to someone. But now I have the ability here, just download that Excel spreadsheet, and there is no built additional add-ins I had to install to get this running. So whatever I'm showing you is if you have, there's an Excel 2010 version and a 2013 version. So it automatically loads that in there, right? And because I downloaded directly from that page, it says, hey, we have a machine learning web service that you have access to, right? So I click on there. If I click on view schema, now it says, hey, these are the inputs that I need for my prediction, and these are the outputs that are going to be provided, right? The cool thing it also does now it wouldn't do this earlier, is you click on use sample data, it will actually pull some of the sample data that you used for the training. And now what you can do is you can actually say, my input is that I want my output to go to G1, and then I hit predict. All right, so that worked. So what just happened, right? When I went through there, I said, okay, that's my input data, right? When I hit predict, it is actually sending this data to this web service that you saw here, because I just downloaded from there, right? No magic tricks, right, so far? No, I didn't change Excel spreadsheets while it's that same spreadsheet. It's actually accessing that web service. And what's happening is it sent all that data, so whatever you see in the input sheet, A1 to F6, it sent that as input. So as part of its output, just as a sanity check, it sends you the input back so that you know what's going on. Now, when I was testing this, it wasn't clear to me why it's assigning these clusters, but apparently, so this column here is what you're looking for, right? The assignments. So what it says is, in my experiment, I had set up to 4 clusters, which meant, take all my data and, if possible, make it up into 4 separate clusters. I'm taking just a small subset of that and throwing it back and saying, hey, where are these? And it says, okay, Boise and Washington are in the same cluster. Grand Rapids, Michigan is also in that 0 cluster. And for some reason, Toledo and Baton Rouge are in another cluster, right? It's not obvious to me. It has to do something with the data. There's sales data in there. There's something about that data which says that those belong together. So if I have a new city, right? So if I'm planning to open my restaurant in a new city, all I need to do is say, get all the same piece of information. What's my Gini index? What's the population? What my land area is? What my population density is? Put that as an input here. Use my web service, and now it's going to say, hey, if you your restaurant here, most probably it's going to fall in cluster 1, for example, right? Now you have the ability to go and say, hey, how are my cluster 1s doing? Are they profitable? If yes, yeah, maybe I'll open my restaurant there. Assume for now that all my zeros are not profitable, right? And so if it falls into the 0 cluster, I'm saying, yeah, I'm not so sure. We need to look more into that, right? So this is the power, right? This is going to transform how you do business. The data, all the additional pieces of data that you have, that's going to come into play when you make these business decisions. And to me, this Excel spreadsheet now, you can send it, like if I send you this spreadsheet the way it is right now, you can use it, right? There are some protective things that I can do to prevent other people from using it, but you know, I haven't done any of that yet. But if I just send you this spreadsheet the way it is now, everyone sitting in this room can actually input data and actually get predictions out of it using this, okay? So there's no add-in. All of this just came along with it when you did the download, okay? Any questions about this so far? Yes.
So the profitability you hinted at, is that hiding in the data set that we didn't see somewhere, or is that in some predictive model?
I don't think that was part of the...
You're saying like it would be in there.
Yeah.
To help you answer the question.
Yeah. The thing is, if they were just looking at profitability, then they would just use that number. But here they're trying to say, hey, you know, there are other things that affect that affect my profitability at the restaurant or whatever. So they're excluding that and using everything else to see, okay, you know, how can I segregate these or separate these and that help me my business.
I'm confused by, you know, on the left you've got the raw data, which is, you know, familiar, makes sense to us humans, and on the right it's normalized, so it no longer means anything.
Yeah. So what I didn't do is I can clean all that up. So what? If I go back to my
populations, for instance.
Right. So there's the ability to denormalize the data. So inside that experiment, the same way you do the normalization. Let me just quickly show you that. So if you look in here, that is actually looking at the transformation that you did. So I did a Z-score transformation. So actually what it's doing here is, you see here the web surface input comes in here, but it doesn't know what the data needs to look like. So it's looking at how you trained the model and using that data to transform it. What I could do is actually transform it back to the original data, and I didn't have that set done here, but all I needed to do is to do a reverse transformation, insert that here, and say, hey, send that to my web service output. So the cool thing is, it takes all of 2 minutes. I drag, drop that module, hit change, and then I just like update web service. Now my spreadsheet is updated. I don't have to even resend my spreadsheet. They open the spreadsheet, now it has the updated model in there.
Is that something somebody like you typically does, denormalize it, or is that like babysitting a noob that wants to still see it like the original data?
I think I normally do, especially when you're sending it to business users who probably look at that and says, oh, that doesn't make sense to me, right? So I've always done that, where I try to hide the complexity on all of this. So I try to strip away all these other columns that you see in here. I mean, I took this example from the gallery, but you know, if I was a business user, I would just only show this column, the assignments, right? That's all I'm interested in. I don't, you know, as a business user, I don't care for all these other things that are going on there. I'm just interested in, okay, tell me where this customer data sits, right? Where these cities sit. So what I would do is, and there's the ability to do that, where you say, hey, take out all the outputs, I just want this thing, and send that to my output. The cool thing about that is you don't have to make any code changes, drag and drop, say, drop these columns, and then send it to web output, and all of this is available, right? Literally code-free, right? I mean, the Excel spreadsheet makes it so easy to test and do all these other things. You want to make more complicated things. So, for example, in the org I worked in, what we did was we needed to run these predictions every 6 hours, right? So we had someone write a .NET application, but even for him it was easy. All he needed to do was have the application run on schedule every 6 hours. It had to create the JSON format, like I showed you there. The C# code was there. He just had to put that in there. And when it ran every 6 hours, it actually collected some information, sent it to the web service, gets the predictions back, and then it was instantly available on our application, right? So the idea with what Microsoft did with machine learning, the Azure machine learning, is to make it so it's not the most powerful thing out there on the planet, but at the same time it's more flexible, it's modular, and it lets you do so many different things. Now, you know, we try to sell some of this stuff to Monsanto. I don't know if there's anyone here from there, but, you know, they have really advanced data scientists who do really complicated stuff, and they look at this and they're like, oh, you know, that's not good enough for me, or something like that. But I would say, coming from the industry, I've seen that something like this gets me started, validates a lot of the data that you see out there without having to go and talk to these data scientists. If I know, and how our project work started off was, you know, we had a data scientist set up one of these, and after that, you know, a lot of us would just go make a copy and then just drag and drop, play around with it, you know, change, create new web services. You know, the cool thing about the studio thing is, like, you can go in here and you can literally, so, and I'm just showing because I think this is just great. You can go in here and say, you know, create a new experiment. So all you do is just highlight all that, Control C, Control V. You just copy now a whole workflow, whole experiment on what someone else has done into your own, right? So the power of this is just amazing, just in terms of productivity and being able to collaborate with other people and so on. It's and it's a literally code-free environment, right? All right, back to Death by PowerPoint. All right, now we're in supervised learning. So supervised learning is where you know what you're looking for, right? Where you're trying to predict something. You're trying to predict income. You're trying to predict if something is going to fail or not. So you have a target, right? So in those cases, you have the ability to supervise your machine learning, and that's what it means by supervised learning, right? So again, you know, when you're walking into one of those school parties and they say, hey, what you been doing lately? Supervised or unsupervised? Went from supervised, right? Now you know what they're talking about. So, and broadly, there are two kinds, classification and regression. Oh, by the way, this joke about the party was my professor from school. We used to say that, and then I used to say, where are those parties? I've never seen those, but it's a hypothetical party that where everyone's a nerd and, you know, they're talking about this. Difference between regression and classification. Classification is more where you have discrete. So you were talking about, for example, discrete categorical data, right? Something will fail or no. You can have multiple categories, right? So here is survive, dead, phase, non-phase, fraud, non-fraud, product categories, right? So that's where you're trying to say, okay, is this something that is high quality, low quality, medium quality, or poor quality? Like, you know, so it's some sort of category. It can be two or even more than that. Regression is where you're trying to aim for a number. You're trying to guess someone's number. Like, for example, price, weight, height, temperature. Microsoft came out with a website, howlook.net. I don't know if you've heard of that, where you uploaded your picture, and it sort of guessed what your age was. So, you know, people had a lot of fun with that, because on the back end is a lot of the machine learning APIs that I mentioned earlier. But it's people uploaded the picture, and, you know, so they do it in the morning, and then at 5 o'clock in the evening after they've had their 5 o'clock shadow, and they do that again, then it's a different age, right? So, and then if you had more of a beard, if you put glasses, then that added to your age. But what's doing there is regression. from a practical perspective, I can tell you that most of the time classification works better than regression because, and I'll explain to you through one of the algorithms, but usually if you're looking at a prediction problem and if you're able to categorize it where you're saying, so for example, when you're trying to predict age, right? Instead of trying to predict, okay, is that person 25 or 26 or 27, you're better off actually going with a category where you're saying that person is there in the 20s or 30s, right? So now you've transformed that regression problem into a classification problem. Usually that works better, and that's just based on how those algorithms work. I can't tell you theoretically why that is, but when you do a whole bunch of these machine learning problems, you will see that they work better when you deal with classification. This is just a simple, if you've done linear regression or straight line fitting in Excel, this is exactly what it is, regression. So here you have some data, you're trying to predict what the ozone levels in the atmosphere are based on some radiation, temperature, wind measurements. So you have 3 variables and you're trying to predict what the ozone levels are, right? And so that's just a simple example of regression. When I say simple, I mean simple in terms of what the data is. You can make it more complicated, and I could go through the whole derivation of how this is all done. And what it's trying to do eventually is really trying to find, if you look at that straight plane there, it's trying to find, what it does, it's trying to move that plane and trying to find the minimum distance from all the points. And so ideally, a good fit minimizes errors. So if you remember, if you've done the straight line fitting in Excel, you look at R squared or adjusted R squared. So that's just looking at that distance. So usually a good fit there will minimize that distance. So that's typically what you do in regression. Here, again, without going into the details of what classification works, the decision tree is a kind of classification, and one of the most effective ones in my mind that Microsoft has that you'll find in Azure Machine Learning is called the boosted decision tree. Prior to that, I thought, neural networks are cool or something like that. But for some reason, for whatever problems that we use, the boosted decision tree that Microsoft has is really effective. Without going into details of what the boosted part means, the decision tree is typically like this. So this is an example from what is known as the Titanic data. So I heard that you guys had a session before where somebody came and talked about the Titanic data. But what it is you have different people, their sex, age, what class they were in the Titanic ship, and whether they survived or not, right? So that's the data that you have. And here I'm trying to explain how you can train a decision tree, right? What I'm trying to prove here is you can create different decision trees from the same data, right? So on this side, you're saying, and normally a decision tree, you start from the top. So you're saying, okay, if the sex is male, then you need to go down. If the sex is female, then yes, they survived, right? Similarly, so you're moving across all the columns, right? And you're trying to say, can I get to a decision of whether they died or not? And that's how you're building the decision tree. So what you're doing there is you're saying, yes, they survived. If they're male, now you're saying, hey, tell me what class they were in. So if they were in the second or third class, no, they died. If they're in the first class, we need to look at their age, right? So if they were less than 29, yes, they survived. They're older than Leonardo DiCaprio, then they died. Or the other way around. But okay, so that's just one way of creating a decision tree. You could create another decision tree that starts with age, right? So you're saying, okay, if they're older than 39, definitely did not survive, right? Then if they're less than 39, look at the sex. Are they male or female? If they're male, look at the class, right? So this is how a decision tree typically works. And this is how you train a decision tree model, right? So what it does is it goes through all the data, builds these different decision trees, and finds the best one, right? So there are very complex algorithms that do this, and that's why I said you don't have to be a data scientist to use this idea, right? You understand the decision. What it does is just breaking up all those attributes. You're trying to predict if someone survived or not, and there are just different ways of splitting up your features. Remember the cool word I talked about, feature engineering? Features. The features that you have here are the age, the P class, the sex, the gender, right? So those are the features, and you're trying to say, hey, can I use those features to sort of predict? And you're just using the decision tree to come to that final conclusion. You'll see these nodes, these final nodes are either yes or no, right? So you need to come to some sort of decision at the end of that tree, right? Did they survive or not? And this is what you're going to use. So so this is just an example of how you can pick two different trees, right? But which of these fit the data best? It gets complex, but I'm just saying there are different ways of looking at the decision tree. So assume we started with this, we picked this tree, right? What does it do to like the test data? And apologize for those who are remote, but what it does is moves this way. So I'm trying to explain to you what the test data is doing against the tree. So I start there, and it says, okay, it's male, right? So my test data says I have a male, so it goes down that tree, right? And then it says the P class is 2, so it goes down that tree, so it says finally no, right? So when I'm testing my prediction, or if I'm sending this to my prediction engine, it uses this decision tree to say whether that person survived or not. So it actually goes through that sequence there that you have on the tree, where it says, hey, first look at the gender, then look at my P class, then look at my age. So it does that across that, and then it says, okay, no, this person did not survive. In essence, that's how a decision tree works, right? You build the model the earlier way I showed it, and then this is how it does a prediction. The interesting thing of this is, and that's why I said it doesn't work great for regressions. If you have numbers that vary from like 0 to 1,000, you can have weird decision trees where, you know, if you're in the middle somewhere, you could belong to someone else and so on. So it's not more than yes and no. If you have 3 or 5 categories, weird things can happen. So generally, that's why categories work better than the actual numbers. All right, so here I have an example. It's demo time again, where we're looking at customer relationships, CRM data, and you have 50,000 rows and 230 feature columns, right? So I don't have to explain what features are, but in this case, it could be something like, you know, this person, some extract from the CRM database that says, you know, this person is, for example, bought product A, but did not buy any of the other products. So you're looking at some of that, and you're trying to predict 3 things. Churn, right, whether that customer is going to leave. Appetency, which I did not know until a few hours back, means what is the chance that they will buy a new product from you. So that's what appetency means. And upselling is where you're trying to sell something of more or higher value, right? But it's a typical scenario that you have. Right, so the question is, given this data, right, is this a person going to leave, right? So you're trying to, yes or no. So this is a binary classification, but you're trying to do that for each of these categories. So you're saying, will they leave? Will they churn? Yes or no, right? So that's one binary classification. Appetency will, what is that? Buy something, yeah, will they buy something new from you? Yes or no, right? And upselling, yes or no. So you're trying to answer those questions from the data. Now, I'm not going to go into the details of how you build this, but again, if I go into my set of experiments, and I created this earlier, right, so this can get complex. So if you look in here, this has 50,000 rows, 230 columns, right? So just like you have that age, gender, and so on, you can imagine now you have 230 columns. How are you going to figure out? This is in no way a humanly possible problem. There's no way you can actually scan through this much data and figure out trends, right? But what is done here is I'm actually going through that. An interesting problem here is missing data. So for example, show you this. There's a clean missing data module, right? So what is that for, right? So for example, in the CRM example, you'll have columns that, for some reason, it's not populated at all. So out of the 230 columns, if you actually look through the data, some of those columns have absolutely no data. And, it's either because that's the way it's been designed, but there's situations where you don't have data. So how do you deal with that? You have the ability within Azure Machine Learning to actually clean some of that within the modules themselves. So here what I'm saying is if something is missing, I'm going to put a substitution value of 0. There are so many cool options in here that I see that and I was like, you know how much code I had to write to clean up my data before, because this is just cool because it does replace with mean, median, mode. So you have the ability to replace missing data. Again, this requires some smarts because you have to know when you can legitimately do that, because sometimes you can't. Sometimes if there's no data in a certain column or something, you need to ignore it, right? So there is some, I would say, business rules that you would put around that, but in essence, I'm just showing you the fact that you can actually do all of that within Azure Machine Learning. So what I've done is here built 3 models. So one which shows my churn, another churn, absency, and the upselling. So I built 3 models, score model, then I combined that, and then I separated out. Again, and then I did a deploy web service. And this took just a few minutes. Get in here. I have this again, right? So I have a web service. One of the things doesn't make sense to show it here because you can't do it here, but you have the ability to try your inputs here on the web itself. In this case, you have 230 inputs, so not a good example. The previous example I should have showed you that you can actually test your inputs right here. If you have a couple of inputs, you can just type them in there and hit OK, and it will actually show you the test without even going to the Excel spreadsheet. But similar thing here, live for you guys to see. Again, same thing. I get an Excel spreadsheet that I can download. I already opened it. So it's the same thing. It creates a web service. It says, hey, this is available. Put your input data and so on. All right. Yeah, I'm going to go quickly because I know I'm going to run out of time here soon. All right. We're done with the demo. And this is the cheat sheet.
You're fine on time.
Oh, okay. I don't know if people want to take a break or just continue. Or
Take a break after.
After I'm done. Okay. But this is a cheat sheet that if you search for Azure Machine Learning cheat sheet, you'll find it. It's available for anyone to use. But this is how you become a data scientist or do machine learning without actually becoming one, right? What algorithm do I pick? So if you start with the big green dot over there, discovering structure, clustering. Anomaly detection. Okay, so that's something that I did in my workplace where we had a lot of sensor data coming from these devices out in the field. We couldn't figure out when these things failed, right? And when you have, we had close to 5,000 of these devices out there with a lot of signals. You want to find out how these things fail. It's very difficult to otherwise find when things are failing. So you use something like anomaly detection to actually say, hey, there's something weird happening here. So that's what you do there. Regression, remember I told you, there's trying to predict numbers. So that's what regression is. The cool thing here is it actually tells you when you need to use the different regressions. So for example, it says here, Ordinal regression is when you have ranked categories where you say something is the best, not as good, and so on. So it's not normal categories. There is some sort of hierarchy in terms of what one is better than the rest, and so on. I'm not going to go through everyone, but I'm just saying decision forest, boosted decision tree, my favorite, my go-to model, boosted decision tree. Two-class classification and multi-class. So two-class is basically when you have either yes, no, failed, not failed, fraud, not fraud. Multi-class is when you have much more than that, right? So you have, multiple categories that you like to predict. And so you pick from one of those models. Depending on what you pick, if you want something that's more accurate, it takes longer to train. You have to make that trade-off, right? So for example, some of these models say, accuracy, fast training, so multi-class decision forest. You're able to do fast training, but then it might not be accurate as some of the other models out there, right? So what do you want? Do you want something that gives you a quick result, or you don't care about how long it takes, I just want the right answer, right? So this cheat sheet actually helps you figure out what algorithm works best for your business needs, right? Again, I'm not going to go through all of this, but I think fair enough to say that for most problems that you see out there in the business world, you'll be able to find a model that works well from here. Rarely would you have to go out into the open source or start with a SaaS or whatever, right? If you already do SaaS or one of those advanced analytics tools in your organization, they might not find this as powerful, but what I say to those people is think about the effort that it requires to deploy and build a model in all those other tools. This is quick, fast, dirty, cheap, and it gets it out there into the hands of multiple people. For my application, that was most important because I needed to get it out, like make changes, and then just send it out. And I would just say, hey, I've upgraded the spreadsheet. You guys load it up. So then I had business people who were sitting there saying, hey, let me see if this works now. And they would put their data like, hey, this works now. And they would give me the green light, and then, it's ready for production. So to me, that was more important than adding complexity, because the interesting thing that I was able to find is basically holes in my data, or holes in what data we have to be, because people would say, oh, we have all the data to predict all of this. You try putting it through one of these things, and then you realize, not really, we don't have everything. Maybe in your mind, you think, so we talk to these experts, say, yeah, you can use this data for all of that. But, we put it through this, and you say, not really. Your data just, you think you can do it, but we can't fit that into a reasonable model, right? So it pointed out holes in the business and holes in the data. The other side of it is once you get these models up and running, people come up with new ideas. Hey, can we sell people on this? Can we sell this as a service, right? There are people who are interested in this data. Can we do this, right? There are a lot of companies out there, Ernst & Young, I know, is one of them, that actually sell products, but they don't advertise in what is inside on the back end is actually Azure machine learning. But they package it as a product where everything is, something that you open up, or a UI that you're familiar with, but in the back end, it's actually Azure machine learning and these models that are here. And I think, if I didn't mention this earlier, all these models were developed in Microsoft Research. Most of these were developed in Microsoft Research, and, it's over, I believe, 20 to 25 years worth of research that's gone in here to build some of these models in here. This one I'll quickly go over, but this is the ability to do notebooks. And this is for people who are used to open source. So when you go and you're trying to talk to someone who says, hey, I do machine learning, but I don't know machine Azure ML. I know Python, I know R. How do we get stuff done? So the Jupyter notebooks are a cool thing to do, and I'll show you how that works. this is an example where you're trying to predict that breast cancer. So you're trying to classify the type of cancer based on 9 attributes. The cool thing is the data for this is in Azure Machine Learning, but you're running it in an R environment. Now, typically R means you have to download and run it on your computer. But the way this works is, if you go in here, right, and so this is a notebook that I created earlier. So Jupyter Notebooks is basically a web-based environment for doing data analysis. And the fancy term that they call it is REPL, right? So this is a REPL environment. I should have looked that up. But it's basically where it's an interactive, right? Where you're typing something, you see a result, you're typing something, you see a result. But on the top right, you see it says R. You have the ability to change that and create a Python notebook as well. So if I go in here and I say change the kernel, that's the internals, to Python, there's the ability to do that. But the cool thing about this that I like is you're writing out a story, right? So you can create this notebook which actually has the story in it. You're talking about, okay, this is my data, this is how I looked at it, right? So it's saying, okay, this is what the data looked like. I imported the data from here. So I'm going, so as you see here, I have, let me actually, right, so if you see here, every time there's this box, it's basically a R command, right? So it's a script that's sitting in there that's ready to run. You have the ability to import external packages too. And R, if people are familiar, there's so many packages that people, universities, different firms come out with. Some are open source, some you pay for, but most of them are open source. So you can find a package that does something that you want to do and actually import it in here, right? So here, now I'm going to run it. So right now you see there's no output here, and then I'm going to run all.
Do you have to install packages every time?
No, you don't. So only those that are not part of it. So there is a whole list. So for example, Python comes from a base distribution called Anaconda. So if it's part of the standard Anaconda install, it will be there. So if it's not, then you have to import it separately. So the same thing with R. I think it's whatever is available in the standard MRO version, Microsoft R open version. All those standard packages will be installed. If it's not, you can just import it. You can just put it in like a folder in Azure, put it on a blob there, and then import it. So what it's done here is actually, it's actually pulling the data, looking at what the data looks like. So it says there's 683. These are the different variables. This command actually just says, hey, give me the top 5 or 6 rows so I can take a look at what that looks like. You can actually do plots. So this is actually doing a correlation plot where it's plotting each variable against each other. And, you know, so those ellipses are sort of showing how correlated they are. If that line stays inside that ellipse, then there's a good correlation. If it's outside, there's probably not much correlation. But that's just these are typical kind of data analysis stuff that, you know, you can do before you start building a model. And then this actually imports a package in here that I can't find right now, but yeah, so it imports various packages. So for example, the ROCR is another package. So you see here it says install package, and then it moves on, right? So it's installing another package. It's saying, hey, this is my model performance and so on. So the cool thing about this is I can now send this to someone else and say, hey, you know, I started off with this. I played around, look at it, and, you know, change it, see if you're getting someone else. If I want to steal someone else's code, and that's perfectly legitimate thing that people do is the idea of sharing our code. Like if you're able to solve some problem, people often share that. So what you can do is you can then import it into this notebook and then, say, okay, just change the data source, and now you can point it to new data and run your same analysis, all those kind of things. So it's a great collaboration tool. You don't need to have, heavy laptops running around to do this. All of this runs in the cloud, and you're able to do R and Python code in this. All right. So, and like I said, you have the ability to switch this and do the same thing with Python as well. And all the examples, by the way, that I showed today are all in the gallery. So anything that you've seen here today, if you look at the gallery, you'll be able to find these examples and actually do a lot of these. There are a lot of examples out there that probably more complicated than you want it to be, but I think there's a whole range. It shows you the ability. You have the ability to embed R and Python code within Azure ML itself without going into the kernel, into the Python notebook. There's the ability to do visualization inside. There's time series data. So, for example, if you're looking at time series data and you want to do predictions based on that, you have the ability to do that. All of those examples are actually in here, connecting to different data sources. All of that is in the gallery. And so everything that I actually showed here, intentionally, I showed you some of that so that you know where to look in case you have questions. And with that, that ends this presentation. No, I don't have an appendix, but that's it. So let me know if you guys have any questions. Go ahead.
Are there places where we actually go see like specific like equations, or is it just basically just a collection of all these, I guess, actions that happen to the data?
Right.
I guess once you get to a final solution, how do you know that's different from some other final solution just by one little thing being different?
Yeah.
How do you know you've saved your final, I guess, equation, so to speak?
Right. So
You have something that works and know you can always go back to it, know that's exactly the way it should be, not be off by something, you know what I'm saying? It's like you don't really see like a set final algorithm or equation that does all this. It's like a whole series of loops and logic, I guess.
Right. So I'll repeat the question for those who are online. So I guess the question is, once you have a trained model, and correct me if I'm wrong, how do you know if that's it's the right one? And if you change it, how do I go back to that model to something that worked earlier? So the way you do that, one is by saving the trained model. So once you build a model, you have the ability to save it. So typically when I worked on it, I worked on it sequentially where I said, hey, this works fine, save it as a trained model, I'll give it version 1 thing, move on to the next one, right? So that's one thing. The other thing that you can do is when you go into an experiment, hit new, okay, I'm not hitting it, but let me open an existing one here. So remember that a lot of these models, because they're proprietary, I would call them black box models, right? They work. There's places where you can plug in and out, but Microsoft does not reveal completely what is inside, right? So that's cause for consternation because you're like, how do you know if that really works, right? So the solution to that is actually what's known as an evaluate model. So there's something in here called an evaluate model, and there's different ways of evaluate models. So one is cross-validate model. So I'll just drag this so you can see the options. Evaluate model, evaluate recommender systems, which I didn't talk about. But cross-validate model is if you say you built your model from 2 or 3 different algorithms, what it does is it takes the data, it actually does an intelligent way of breaking up the data. So it takes like, for example, the first 10 pieces of data and then checks it with everything else. Then it randomly picks another 10, builds another model with that, and checks if that model works with the first model, throws that away, picks another 10. So that's what cross-validate is, where it takes different pieces of the same data, sampling it. So if you think about it, there's some statistically, if you're sampling properly, then your models must all be similar. So that's one way of cross-validating your model. So you don't really need to know the internals. You just need to know whether my model is consistent across cross-validation. The other thing is evaluate models, where you're taking the same data set, but you can plug in the boosted decision tree, you can put in a neural network, bring in your own, right? You have the ability to bring in your own models in here from outside, like SAFe. Somebody who is a data scientist did something in R that he said, hey, it works really well. You can actually bring that same model in here and use this evaluate model and give some parameters and say, okay, I want accuracy. When you come to multi-class classification, there's the ability beyond accuracy. We talk about can I predict more positives versus negatives, right? So a good example for that is a machine that is checking for cancer, for example, right? You normally want it to find cancer even if there's the remotest possibility, right? So if there are ways of tuning that parameter where, it could say most of the time there is something, or it can create false positives. So there's ways of tuning those parameters. The point I'm making is just that there are tools in there to actually compare different models, and you can use that to actually compare. But that's one of the questions when I started playing with this is, I don't know what you guys are using, so I don't know if this works or not.
How do you trust what's behind the covers?
Yeah. So the only way to do that is really by comparing the different models, and eventually it comes down to testing it against other data. So normally, when you do any sort of machine learning experiment, you take all your data, you break it up into 3 pieces. One piece of data is called the training data. The next piece of data is called your test data. The third piece is called validation. So you take your training data to build your model against. And then your test data is what you compare it for finding your final model. So if you're comparing like 3 different models, you take 3 different models and use the test data to compare against that. And then you get to a model, so this is, it's kind of like these mathematicians just it seems like they're just being analytical or anal, if you will, right? In terms of, okay, I got this from 2 pieces of data, I want to test it with a third set. And then they keep an external set that has not seen this model at all and say, okay, does it work well against that? And typically hardcore people who do data science, that's what they do. They break all their data into these 3 sets. So they do the training, the test, and the validation. And you can do that here without actually even going to the internals of the data. So, any other questions? No.
I saw a sneak peek at something interestingly called metadata.
Right.
Like in a situation where there's an area expert, the head of engineering, that's trying to add attributes to the data. He looks at the data and comes up with little different patterns. But is there a way to get input from somebody else as you're training the model? Without him having to do the obvious, he creates his own data set and that sort of thing?
Right now there is no ability to externally influence. What you could do is you have the ability to retrain. So this is in the case of, for example, and we heard this from a customer that did banking fraud, right? So they said the model worked fine for the first 3 months, and then it started to deteriorate, right? So I asked some questions to those people who were implementing it. I said, did you do retraining? Because if you think about it, what is it that somebody who wants to hack into a system or trying to break into a system figure out? They learn too, right? So you built a model that's detecting fraud based on some piece of data or some attributes, but that changes over time. So what you can do is you can set up retraining as a continuous feature so that you're always rebuilding your model based on newer data, based on newer information, and updating your web service. So in the case that you mentioned, the only way that I see currently they can do is actually retraining the web service with that fresh data and have it flexible to where it says, I'm always looking at this table that could have maybe more columns. Maybe someone is adding one more column next week. You could start off with that and then retrain based on that. There are abilities within Azure Machine Learning to always reduce the number of columns. So regardless of whether you start with 10 or 15 or 20 or 200, it will, within the model, it will reduce it down to 10. So that way you're always building models. You can always build a model because you're inside Azure Machine Learning, you're always dealing with a fixed number of columns. Anything else? Pretty good? All right. Thank you, everyone. And if you have any questions, you saw my email. Ask one of these guys. They're out here. Myself. We have another data scientist who's also here in the office. She's not here this week, but we're always here to answer your questions. Right? All right. So I can stop sharing.
Yeah, you can stop sharing.
Okay.
Can you stop the recording?
Yep.
So please fill out your evaluation sheet where you